Good morning. My name is Rupesh Kumar. I am going to discuss the topic phenol. First, we should know what is phenol. When benzene ring attached with hydroxyl group, this chemical compound is called phenol. This is benzene ring. When hydroxyl group attached with this benzene ring, this chemical compound is considered as phenol. Here we can see OH group is attached. It is very common for alcohol. We know about alcohol. What is alcohol? Alkyl group attached with hydroxyl group is considered alcohol. For example, C2H5 when attached with OH group compound is C2H5. This is ethanol. Ethanol is example of alcohol. In both OH is common, but both are not same, because in this OH is attached with sp2 carbon, while in case of alcohol ethanol, OH hydroxyl group attached with sp3 carbon. This is the main difference between phenol and alcohol, and due to this difference, attachment of hydroxyl group with different hybridization of carbon, acidic behavior differs. Acidic character depend on stability of conjugate base. In case of phenol, conjugate base is phenoxide ion. When we remove H plus from the phenol, this will convert to this type of ion. This is known as phenoxide ion. While in case of ethanol, when we remove this H plus, then compound will be this. This is called ethoxide ion. Phenoxide ion is resonance stabilized, because there is a chance of resonance due to this ring. But in this case, in the case of ethoxide ion, there is no resonance. That's why it is more acidic. By data, it is 10 to the power 6 times acidic than ethanol. This is the resonating structure. There are 1, 2, 3 and 4. 4 resonating structure of phenoxide ion. Here we can see there is partial negative on ortho and para position. I am going to draw resonance hybrid. This is resonance hybrid. Partial negative is present on the ortho and para. This is very important. We should remember this. Not remember, but we should learn this. When substituent attached on the phenol, acidic character changes. In this, at ortho position there is NO2 group. In this CH3 there is no substituent. Due to this, acidic character changes. In this, NO2 so minus I as well as minus M. This increase the stability of phenoxide ion, so A will be most acidic. In this case, CH3 will so plus I. It will destabilize the phenoxide ion. It will be in the least position, and there is no effect. So C will be in the between. Acidic character of the substituent having phenol is like this. We can conclude when if there is electron withdrawing group, acidic character increases. This is electron withdrawing group. That's why acidic character increases. When there is electron donating group, acidic character of phenol decreases. On this, there are many questions asked in examination. We will see. These two questions are related to acidic character of phenol. First question is, arrange the following in increasing order of acidity. This is asked in JEE Main 2022. Here 3 examples are given: phenol, para-nitrophenol and para-methoxyphenol. Do you know this is phenol? Para-nitrophenol. This is ortho, meta and para. At para there is NO2. In this case, methoxy group. This is methoxy group is attached. So as we know, acidic characteristics depend on the stability of phenoxide ion. Phenoxide, here there is no any substituent. Here substituent NO2. As we have discussed, it will show minus I and minus M. Here is lone pair, it will show plus M. This is Hughes factor to stabilize the phenoxide ion. So most acidic will be B, and plus M will decrease the stability of phenoxide ion. So it will be the least, and A will be the in between. Another question is assertion reason type. Phenol is more acidic than alcohol. This I have already discussed in detail. And for this assertion, reason is given: phenoxide ion is resonance stabilized. It is very clear that both are true, and second is the reason for the assertion. And this question is asked in 2019. So this is very easy questions from acidic character. Next, I am going to discuss some important chemical reactions of phenol. First reaction is bromination. From what word bromination, it is very clear that we are going to add bromine on phenol. This is phenol. I have taken two reactions. First is bromine in presence of CO2 and CCl4. These are solvent. These are non-polar solvent. When bromination takes place in case of non-polar solvent, there will be formation of two types of products. First is para-bromophenol and another is ortho-bromophenol. This product is 80%, this is 20%. Why there is difference? Difference is due to steric hindrance. This compound has less steric hindrance, and this has more steric hindrance. That's why it is at 80% and this is 20%. When we can see the formation of product in presence of H2O. H2O is polar solvent. Here product is very different from this. Here this is monobromination only, while in this case there are 3 bromines added. This is tribromo product. Its name is 2,4,6-tribromophenol. Why there is tribromination and here is monobromination? I have written this question: why monobromination takes place in presence of solvent like CCl2, CS2 and CCl4, while tribromination takes place in presence of H2O? The reason behind this is in H2O is polar solvent, and in case of H2O there is formation of phenoxide ion. This is phenoxide ion. When there is formation of phenoxide ion, it is more activating. But due to more activation nature of phenoxide ion, more bromine get attached when there is a possibility of partial negative charge. So we know that there are three positions, 2 ortho and 1 meta positions, where there is possibility of negative charges. At all the 3 positions, bromine will add it. While in case of non-polar solvent, it will remain neutral. So there is less bromination. Now we will see question related to this, which is asked in JEE Mains question. These 2 questions is asked from the topic bromination. First one is asked in 2021 JEE Main question. First is phenol react with bromine water to give. We have discussed about this. Water is polar solvent, and when we use polar solvent, there is formation of phenoxide ion. Phenoxide ion is more activating. That's why there is chance of the maximum bromination, and bromination takes place when there is a partial negative charge, and partial negative charge is possible on ortho and para position. Ortho and para position. Here will be bromination, here also will be the bromination, here will be the bromination. Why this happens? Due to presence of phenoxide ion. Answer is very clear, it is C. Next question, which is asked in JEE 2026 2. Phenol in non-polar solvent like CH2 with water. This is non-polar solvent, already discussed in question. In case of non-polar solvent, it is less activating as compared to the previous one, so there is chance of the less bromination. Phenol will show plus M effect, but it is not activating as compared to the phenoxide ion, so there is chance of only monobromination. Answer will be A. Now we should move to the next reactions. Next reaction is Riemann-Tiemann reaction. In this reaction, when phenol is treated with chloroform in presence of alkali NaOH, then there is formation of salicylaldehyde. This is common name. Its IUPAC name is 2-hydroxybenzaldehyde. This reaction is very important from this examination. Question is asked frequently. After discussion, I will discuss question related to this. First, we should know how this happens. How this reactant convert into product. This is phenol, and how phenol goes into 2-hydroxybenzaldehyde. Here is the mechanism. In presence of NaOH, it is alkaline in nature. I can write this in this form. OH minus subtract H plus ion, and this convert into phenoxide ion. Further, in case of chloroform, there are 3 chlorine attached to the carbon. All this will show minus I effect, and due to this hydrogen become more acidic, and with the help of NaOH, again H2 will be removed, and this type of intermediate is formed. This is very unstable. Why this is unstable? Because carbon is not that much electronegative and its size is smaller, and there is a negative charge on it. That's why one chlorine will remove out from this, and there will be formation of an intermediate. This is very important. This is called carbene. It is sp2 hybridized, and this is neutral and electron deficient also. This is a very important intermediate. We have to remember, in Riemann-Tiemann reaction, formation of CCl2 take place, carbene dichloride take place during this reaction. Because this is electron deficient, now phenoxide ion come in the action. Here negative charge delocalized, and this double bond shift here, and attack take place at this. And here is the formation of this type of compound. Again, for gaining aromaticity, this H plus will get removed out, minus H plus. This type of compound is formed with the help of again NaOH. There will be 2 NaCl will remove out, and the formation of 2 OH, 2 hydroxyl group will introduce on the carbon atom. This is also very unstable. That's why H2O will remove from here, and there is the formation of aldehyde on ortho position, and after protonation we will get 2-hydroxybenzaldehyde. This is mechanism of the Riemann-Tiemann reaction, and this important is formation of carbene as intermediate. In short, I can say that when phenol is treated In presence of CH3 and NaOH, there is the formation of this type of, this is considered as intermediate. And when we treat with NaOH, this convert into aldehyde, and after protonation we get salicylaldehyde. Now the question is, why there is a formation of ortho only? Why there is not the formation of para? Because phenoxide ion produces negative charge on all three positions. But as you can see, there is a chance of hydrogen bonding. There is chance of hydrogen bonding. This due to hydrogen bonding, product formation take place on ortho position. Here I have written why only ortho position. Due to formation of hydrogen H bonding, which is a large factor for the formation of product at ortho position. Ortho. That's why in case of Riemann-Tiemann reaction, introduction of aldehyde take place at ortho position. Now these two questions belong to Riemann-Tiemann reaction. Here first question is, phenol react with CHCl3 and NaOH to give major product. I have already discussed phenol reacts with CHCl3 chloroform and NaOH. From the question it is very clear that this is asked from Riemann-Tiemann reaction. What was the product? The product was salicylaldehyde. And this is salicylaldehyde. The first option is benzaldehyde. This product is not benzaldehyde because there is OH also. So this is not correct. Next option is orthohydroxybenzaldehyde. Orthohydroxybenzaldehyde. This is 1, 2. This is ortho, meta, and para. So there is ortho. This should be correct. Let's see. I have already told that due to hydrogen bonding, this type of product form. When there is presence of OH on para position, there will no hydrogen bonding. So this is incorrect and this is also incorrect. Next question is, the electrophile in Riemann-Tiemann reaction is. Electrophile is electron deficient. This can't be answered because there is negative. And in Riemann-Tiemann reaction there are no CO2, no Cl+. The only option is dichlorocarbon. This question, this is asked in JEE Main 2022 and this is asked in JEE Main 2021. Next important reaction of phenol is Kolb's reaction. What is Kolb's reaction? In this, phenol is treated with NaOH in presence of CO2. Then there will be production of salicylic acid. Salicylic acid is common. Its common name. Its IUPAC name is 2-hydroxybenzoic acid. How this formation take place? For this, we should go through the mechanism. Mechanism is almost similar to the Riemann-Tiemann, not exactly, but there is similarity. In this also, OH minus and H plus. This is basic. This is respect H plus, and there will be formation of phenoxide ion. Again, phenoxide ion. This negative charge shift toward the ring. And CO2 is, in case of CO2, carbon is electron deficient due to higher electronegativity of these two oxygen atoms. And here negative charge attack on carbon. Carbon cannot form 5 bonds. That's why this pi bond will shift toward the oxygen, and the negative charge on oxygen is relatively stable as compared to the carbon. And this hydrogen, for gaining aromaticity, this hydrogen is abstracted by this oxygen minus, there is a formation of COH, and again after protonation, there is formation of salicylic acid. This is simple mechanism of Kolb's reaction. This reaction is very important, and questions are frequently asked in JEE main examination. We will discuss question related to this. These two questions are related to Kolb's reaction. First question is phenol react with NaOH and CO2 under pressure to form. This is phenol reacts with NaOH and CO2. If we remember the mechanism, it is very easy to find out the product. What will be the product? Product will be OHCOH. This is salicylic acid. Answer will be benzoyl yet because CO2 convert into acid. This is not answer. This is a correct. OH will not remove. That's why not be benzoic acid, and this is not the option. Major product of Kolb's reaction. Which will be the major product? Meta, ortho, para, या no preference. In Kolb's reaction, product is this, and this is called ortho position. Why ortho position? Why ortho is major product? Here again reason is hydrogen bonding. Here you can see hydrogen bonding among this. There is hydrogen bonding. That's why formation of CO2 take place at ortho. This is ortho, this is meta, and this is para. Note at meta because this is not activated. Para is activated, but there is no chance of hydrogen bonding. That's why product formation take place on the ortho position. These two reactions, Riemann-Tiemann reactions and Kolb's reactions, are very important, and both there is similarity between these both. We should remember this. That's all. Thank you.